So what if an AI could stop thinking like a lone genius and start working like a super efficient expert team? We're right on the edge of a massive shift in AI, moving from this idea of a single, solo mind to a whole collaborative organization of AI agents. And the secret sauce to making this happen? It's a really powerful new method called asynchronous thinking.
All right, so here's how we're going to break this down. First, we'll look at the problem AIs have with thinking right now. Then we'll get into the breakthrough solution, asynchronous thinking. After that, we'll meet the virtual AI team that makes it all work, check out the pretty staggering performance data, and finally, look ahead at what this means for the future.
To really appreciate why this is such a big deal, we first have to get a handle on the current bottlenecks. Why does AI even need a new way to think in the first place?
Well, traditionally, large language models have kind of two main ways of reasoning. The first is sequential thinking. You can just picture a single train of thought chugging along one step at a time. It gets there, but man, it can be slow and stuck on one track. The other method is parallel thinking. This is more like having a bunch of people brainstorm the same problem, but in separate rooms. Then they all come back together and vote on the best idea. It's an improvement for sure, but you're always held back by the slowest person, and that final step of getting everyone to agree, that takes time.
So, these limitations get you thinking, and they lead to a really powerful question that basically reframes the whole problem. What if, instead of just thinking faster or having more solo thinkers, an AI could actually learn to collaborate with itself, like a real team?
And that question, right there, brings us to the incredible solution proposed by researchers at Microsoft. They've come up with a whole new paradigm that takes AI from being a solo act to being a coordinated team.
The big vision, the grand idea, is something called Agentic Organization. The goal is to build a system where lots of AI agents can work together at the same time to solve problems that would be impossible for any single agent. It's literally about creating a whole that is way, way smarter than the sum of its parts.
Okay, fantastic vision, but how do you actually make it happen? Well, the specific technique they developed is called AsyncThink. You can think of it as the playbook, the framework that teaches one single language model how to manage its own internal thought process so that different lines of reasoning can happen all at once, and, this is the crucial part, they can actually work together.
So, how does this AI team actually function day to day? It really all comes down to this clever little system where the AI learns to play two totally different but complementary roles. First up, you have the organizer. Seriously, just think of this as the project manager or the team lead. Its whole job is to look at the big problem, slice it up into smaller, doable pieces, and then hand those pieces out. It's the brains of the operation.
And who gets those tasks from the organizer? The workers. These guys are the specialists. A worker gets a super specific job, puts its head down, focuses all its energy on solving that one thing, and then brings the result back to the organizer.
And the way they interact follows this simple but really powerful three-step dance. First, the organizer uses a fork command to basically delegate a task to a worker. Then comes the think phase. And this is the magic part. While the worker is off grinding away on its task, the organizer isn't just sitting around. It can keep doing its own thing, maybe prepping the next task. Finally, the organizer uses a join command to pause for a second and bring the worker's finished piece of the puzzle back into the main plan.
Now, if this still feels a bit abstract, this analogy should really make it click. It's a lot like the computer you're probably using right now. A single agent, whether it's an organizer or a worker, is like one CPU core. So the pool of all the available agents is like your multi-core processor. And the organization policy, the AsyncThink protocol itself, that's the software, the program that's intelligently telling all those cores what to do and when to do it so everything runs smoothly.
Okay, this all sounds amazing on paper, right? A perfectly organized little AI team. But does it actually work? Does it deliver? Let's get into the results, because the performance data here is pretty jaw-dropping.
So this is the headline. This is the crucial takeaway. This isn't a trade-off. We're not getting something that's faster but dumber or smarter but slower. The research shows that on really tough math problems, AsyncThink was both faster, that inference latency is just a fancy way of saying thinking time, and it was more accurate. Getting both at the same time is a massive win.
And let's get into the specifics. They gave it this really hard problem-solving test where the goal wasn't just to find one answer, but 4 different correct solutions. And look at these numbers. AsyncThink nailed it with an 89% success rate. That just blows the other methods out of the water, which were both stuck around 70%. This shows it's not just better at finding an answer, it's better at exploring the whole problem and finding all the right answers.
And here's that speed boost we just talked about, illustrated perfectly. A 28% reduction in latency means it's finding the solution almost a third faster than the next best method. It's just thinking way more efficiently because it's dividing up the work so intelligently.
But honestly, this might be the most impressive result of all. After training the AI on all those number puzzles, the researchers threw it a total curveball, a task it had never seen before, solving Sudoku puzzles. And just look at that. AsyncThink took the collaboration strategy it had learned and applied it to this new problem, and it still performed better. This is huge. It proves the AI didn't just memorize a procedure, it actually learned a fundamental skill, how to organize thinking.
So, when you put it all together, the takeaways are just crystal clear. This new way of thinking leads to AI that's more accurate, way faster, much better at breaking down big, messy problems, and, incredibly, it can adapt to new challenges it's never even encountered before.
Yeah, this is so much more than just a little improvement. What we're looking at is a foundational shift, a new building block for a much more powerful and collaborative future for AI. And the roadmap from here is just fascinating. Researchers are already looking at how to scale this up to huge AI organizations with hundreds, maybe thousands of agents all working together. They're also exploring this idea of recursive organization, where a worker could become a sub-organizer and create its own little team to solve its task. And maybe the most exciting part, building hybrid human-AI teams, where a person could be the organizer, handing out tasks to AI workers, or an AI could fork a task that needs a human's touch.
And all of this, it leaves us with one final, really provocative question. For years, we've been focused on making AI smarter. But now, we're teaching it how to be a team player. What new frontiers in science, in medicine, and creativity are we going to be able to cross when our most powerful thinking tools finally master the art of collaboration?